Hello and welcome to my science tutorials. In today's video, we want to learn about the change of subject. Right, so without further ado, let's begin. So one of the most frequent things we do in mathematics or in science is always to find an unknown variable or to make an unknown variable or quantity the subject. You get to do this when you are dealing with formulas and you have to find another parameter that is not a subject of the equation or of the formula. So for instance, let's say we have a is equal to bx plus cy cube. Let's say this hypothetical equation, and we've been asked to find the value of b. In most cases, it is easier for us to find b if we make b the subject. If we make b the subject and then substitute the value of x, c, y, and then a if they are given, we do the substitution and we get our answer easy. So for us to make b the subject, it means we have to bring b to where the current a is over here, or we equate every other parameter or every other variable to what we are to make the subject, that is b in this case. So if we do that and we rewrite this equation to make b is equal to maybe a plus cy cube or something like that, this becomes our subject and that is what we want to look at. We want to look at how to make a variable the subject in today's video. All right, so let's start with a typical example. So assuming we have a is equal to 1 over 2 a plus b multiplied by h, and over here we have to make small a the subject, so make a the subject. All right, so how do we make small a the subject? Now if you look at this particular example, you realize that we have a is equal to half multiplied by a plus b multiplied by h. They are all multiplying each other together just as one term. Okay, there's they are not different from each other, they are just one term. Everything is multiplying each other together. So in this particular case, the first thing we need to do is to get rid of the fraction that we have over here to have the equation in a more linear way. After that, we try to isolate a and make a stand alone, and then we make it the subject. So the first thing I do is I multiply through by the LCM. So I have a is equal to half multiplied by a plus b multiplied by 8. So I multiply through by 2. Okay, the 2 here becomes the LCM, so I use 2 to multiply through. So I have 2 multiplied by a will be equal to 2 multiplied by half into bracket a plus b h. So 2 multiplied by a will give me 2a is equal to, this will cancel this, so I'm only left with a plus b h. Okay, so from here the next thing I can do, okay, is to, I can see I have a plus b multiplied by h. There is h here, we don't want h to be there, we want a plus b to stand alone, and after that you can make a to stand alone. So the first thing I do over here is I divide through by h. So this cancels this, so I have 2a on h is equal to a plus b. Now that I have this alone, I cannot make a the subject by maintaining the a here and bringing the b to the other side of the equal to sign. So if I do that, I have 2a on h. Then if I send the b to the other side of the equal to sign, it becomes minus, so minus b is equal to a. So therefore, it means that if I make my small a the subject, I'm going to get the expression 2a on h minus b. This is h. So this becomes my answer for the expression I'm supposed to make the subject. All right, so what if we have another example? Let's look at another example. So we have to make t the subject in we have to make t the subject in the simple interest formula below. So make t the subject in the simple interest formula. Interest is equal to principal multiplied by the rate multiplied by the time, all on 100. Right, so this is the formula we use to calculate simple interest. If you go and borrow a money, which is your principal, at a particular rate over a duration of time, this is the formula that we use to calculate the interest that will be added onto your principal for you to pay. Now we've been asked to make t the subject over here. Alright, so the first thing we do over here is to multiply through by 100, since we have a fraction over here. So we use 100 to multiply through. So we have 100 multiplied by interest is equal to principal multiplied by the rate by the time on 100 multiplied by 100 as well. Since this is one term, another term, we multiply both terms by 100. So this gives me 100i is equal to, this cancels this, principal multiplied by rate multiplied by time. Alright, so because principal, rate, and time are multiplying each other, and I want the time to stand alone, I divide through by principal and rate. So the time is now equal to 100 multiplied by the interest on principal multiplied by the rate. So that becomes the subject. After we make t the subject, this becomes the expression that we get for our answer. Alright, so let's make x the subject in the formula given below. So make s the subject in the formula v is equal to w root of a squared minus x squared. Alright, so we have the expression v is equal to w the root of a squared minus x squared. Alright, so we have to make x the subject, and we can see that the x is embedded in a root sign. So the first thing we need to do is to get rid of the root sign. We do that by squaring. Okay, so we square both sides of the equation. So we have v squared is equal to w the root of a squared minus x squared squared. Now this will give us v squared is equal to, these are w and the content in the root sign are multiplying each other. So if we square all of them, we will have w squared, then the square root will cancel this, so it becomes a squared minus x squared over here. Right, so now that we've gotten rid of the root sign, the next thing we need to do is to make sure that our x term is standing alone. We can do that by, first of all, dividing both sides by w squared. So this cancels this, so it means we have v squared on w squared is equal to a squared minus x squared. Right, so from here, let me get some space. Okay, so from here, the next thing we need to do is to rearrange the equation to make s squared stand alone. So I'm going to bring s squared, let me maintain s squared here. So I have v squared over w squared, then I send the a to the other side of the equal to sign, becomes minus a squared is equal to negative x squared. So this is the expression that I have. So from here, all I need to do, okay, is to first of all get rid of the negative over here because I don't want that. So I divide both sides by negative, by negative. So this cancels this. It means s squared will now be equal to v squared on w squared divided by negative will give me negative v squared on w squared. Negative a squared divided by negative 1 will give me positive a squared. So I can rewrite this equation as s squared is equal to a squared minus v squared on w squared. Alright, so from here I need to make x stand alone. I can do that by finding the root of this equation. So I bring my root sign here, bring my root sign over here. So this cancels this. So my x as the subject now is not equal to the root of a squared minus v squared on w squared. So this becomes my answer if I make x the subject. Right, so let's proceed. So let's try the following question. So example number 1, we are to make m the subject, make m the subject in E is equal to mgh plus half mv squared. Then example number 2, make r the subject. We are to make r the subject in 1 over r is equal to 1 over r1 plus 1 over r2. This is the formula that we use to find the total resistance of resistors connected in parallel. Right, let's look at the last example. We have to make D the subject in u squared minus du plus fd is equal to 0. Alright, so let's write down our solution. Please, you can go ahead and try the questions, make the various m, r, and then d the subjects respectively, and then let's see our answer at the end. Right, so in the first one we have E is equal to mgh plus half mv squared. Alright, so we were asked to make m the subject. Before we do that, we can see we have a fraction here, so let's get rid of it. We do that by multiplying through by the denominator over here, which is 2. So we multiply each term, e, this term, and then this whole term as well by 2. So it becomes 2 multiplied by e is equal to 2 multiplied by mgh plus half mv squared multiplied by 2. So we have 2e is equal to 2mgh. These two will cancel this, so we have plus mv squared. Alright, so from here we can see that we have m common in here, so we can factor m out. So we have e, 2e is equal to, then I factor m out, I have m outside bracket into bracket 2gh plus v squared. So if I multiply the m by the content in the bracket over here, I get 2mgh. If I multiply m by the v squared, I get mv squared. So from here I have 2e is equal to m 2gh plus v squared. I'm just repeating this. So from here I can divide both sides by 2gh plus v squared, 2gh plus v squared. This cancels the whole of this. So my m as the subject will give me the expression 2e all on 2gh plus v squared. So that becomes my answer for the first expression. Alright, so let's go ahead and find the solution for the second expression. So for the second expression, we were given the expression or the formula 1 over r is equal to 1 over r1 plus 1 over r2, and we're asked to make r the subject. Alright, so the first thing that we do in this case is we maintain this 1 over r is equal to, we have two fractions being added to each other. So we need to find the LCM for these two. The LCM in this case, because they are variables, they are not numbers, we multiply this and this to get the LCM. So we have R1, R2 as our LCM. Now R1 will go into R1, R2. So R1 will cancel R1. R1 will cancel R1. We are left with R2. So we have R2 here. Plus R2 will cancel R2. We have R1 left, multiplied by 1 is still R1. So from here, what we can do is we can reverse this, flip this and flip this to get our answer straight, or we cross multiply over here. So this R will multiply what is at the top, 1 will multiply what is at the bottom here. So we have R into bracket R2 plus R1 is equal to 1 multiplied by R1 R2. So from here we can divide both sides by R2 plus R1, R2 plus R1. So when we do that, we have our expression for R to be equal to R1 R2 on R2 plus R1. Okay, now let's look at the final expression that we're given. So we're given u squared minus du plus fd is equal to 0, and we're asked to make d the subject. All right, so this is pretty much very easy, very straightforward. We're asked to make d the subject, but first of all, let's group like terms, okay, so that we make this easy. So I'm going to maintain my u squared here to be equal to, then I send the other component of the equation that has dd attached to them. I'll send it to the other side of the equal to sign. So I send the negative du here, it becomes positive du. Then I send the positive fd, it becomes minus fd. Okay, so from here I still maintain my u squared is equal to, between du and fd, d is common, so I factor d out. So I have d outside bracket into bracket u minus f. Now I have my d multiplying the content in the bracket here. I have my u squared over here. So to make my d stand alone, I divide both sides by u minus f, u minus f. This cancels this. So my expression for making d the subject becomes u squared on u minus f. So this becomes my answer after making d the subject. So thank you so much for watching. I hope and believe that this brief video gave you the impression and how easy it is to make something or a variable the subject. It's just very easy. You just have to know how to maneuver your ways. When you have a fraction, you make sure you get rid of the fraction first. If you have square root sign, you make sure you get rid of the square root sign. If you have bracket, expand the bracket, rearrange your term. If you have your variable that you have to make the subject appearing more than once, make sure you factor it out to have it stand alone. Then you group the other components that are not attached to it to the other side of the equal to sign and make your variable that you've been asked to make the subject, to make it the subject. So thank you once again for watching, and I'll see you in the next video. Bye bye.